Our next speaker is John Savage. He's the CTO of Action Point, based in Limerick. John has just come from the National Manufacturing and Supply Chain Conference in City West this morning. He's trundled down the motorway, not collecting too many points, I hope. So he's here to talk to us today about not only his company, but to give us an insight into some interesting projects that they've done in the IoT space. John will introduce his company in a minute, but just a word about John. First of all, John is a first-class honours graduate from the Computer Systems from the University of Limerick. He's one of only 3 graduates in the university's history to graduate with a perfect QCA score of 4.0. I understand how difficult that is because I graduated from the same class in the same year, and I wasn't one of the other 2. A visionary strategist and technologist, John's core competencies focus on helping companies transform their business processes and systems via a deep dive of their business goals and strategy. This approach allows him to guide his team and devise a software solution that goes beyond the code to provide measurable business value. John will talk about the maturity and adoption of intelligent technologies like IoT, AI, blockchain, augmented reality, and more, and take us through a concept to concrete IoT project which his company has delivered. So welcome John to the stage.
Appreciate it. I just had a mic check, so hopefully it's good. You hear me okay? All right. So unfortunately I have to follow that intro now, so that's pretty tough. So yeah, thanks for the opportunity to talk to you guys. I came up here expecting a small group of developers and was very impressed with the scale and scope of what you guys have on display out here. So it's a pretty impressive team you have. So what I want to do is give you a bit of background on Action Point and our own story, but mainly focus on kind of future technologies. So a bit of background on what we do will kind of give you insight as to why we deal an awful lot with kind of the next generation technologies. And then also look at essentially an awful lot of what we do is we take people's concepts and ideas and we turn it into real life software in loads of different domains again and again and again. So we've kind of honed our approach and our mindset on how we do development to drive that journey from concept to concrete as quickly and efficiently as possible in everything from small, medium to large enterprise multinationals. And essentially finish off with an example project that touches on some of the buzzwords, touches on some of the modern technologies, IoT, machine learning, and some AR as well. Just give you kind of some grounding in reality as to where these technologies can actually give big value and big benefit to end users, essentially. So I'd like to just say as well, I'm happy for interaction, so if anyone has any questions along the way, if anything's not clear, then raise the hand. I've been informed I've got to throw this box at you, but be warned, my aim isn't the best, so who knows where it'll go. If you catch it, you have to ask me a question though. So background on Action Point, I think, is there a slide? Yeah, so essentially founded by myself and another colleague from the same course as Brian in a year I won't mention. We graduated from UL, went off for 4 or 5 years working together, and then we came back and we set up Action Point as a company doing custom software development. So we then branched into IT managed services as well. So we do the full gamut of IT and software development, and we're one of the few companies in Ireland that actually has enterprise grade custom software along with enterprise grade IT services under the one roof. We're at 97 employees, and that would have been 87 yesterday. So it was announced only today we purchased an IT services company in Lisburn. So I actually didn't come from Dublin, I came from Lisburn. I came from Dublin via Lisburn, basically, so I've been on the road quite a bit in the last few days. But yeah, we purchased a company up in Northern Ireland on the IT services side of things, and we're looking to, over the next couple of years, continue that strategy and grow the organization. Revenue's 15 million, national international presence, and we've won a few awards along the journey as well. So the Scalar projects, just kind of give you a scope. The company kind of generally runs 6 man-year plus projects are kind of our really sweet spot for the projects we really like getting stuck into. They'd be kind of 2 million plus, multinational. So generally speaking, there's not that many projects of that scale in Ireland. So we really are focusing the software side of the business abroad. Business process automation is a large part of what we do, legacy application redevelopment, and then systems integrations as well. So bringing loads of different pieces together. So while we've never worked within the SAP platform, we have actually integrated quite a lot with SAP in various manufacturing environments over the last few years. So I've familiarity with the technology stack. And then as well as being loads of different types of projects in loads of different domains, we also cover every type of technology. So IoT, HoloLens, machine learning, blockchain, bots, it's buzzword bingo, and I could keep going for a while. But basically, if there's new technology, we get asked about it, and that's where we got to look into it and kind of be at that bleeding edge with our customers. Some sample projects, again, just to ground in reality what we do. So probably the project you've heard of in the last couple of months would be the online passport renewal system. So in Ireland, next time you're renewing your passport, or if you've renewed your passport in the last year and a half, if you've done it online, that's our software. So essentially, I renewed my own passport actually the week before Christmas. Took me 8.5 minutes to run through the process on the Monday morning, and my passport was in my letterbox on the Wednesday. So that's the level of process automation we brought to a process that used to be at least 15 days turnaround time. So huge success, and actually on the back of that, I'm flying out on Sunday to the Philippines to talk to the Filipino government to do something similar for them. So these sorts of big, large projects are great for Ireland to be seen on the international stage as well as a technology leader. National herd management, so we're working, if there's any farmers in the room, I'm sure there probably are, we're working closely with the Munster Cattle Breeding Group to take all of the data that they get across all of the systems around the creameries, the co-ops, and the genealogy that we have in Ireland of all the cattle over the last 20 odd years, and turn it into a decision support tool that's in the hands of farmers to help them increase the efficiency of how they manage their herds. So we're doing large-scale AI and data analysis to deliver tools into the hands of farmers to hopefully increase the turnover in Ireland. We're working with the FIAs, I won't do the French version, it's the Formula 1 guys, Fédération Internationale Automobile, I think. But basically, we're working with them to do a global project to roll out licensing for drivers, race car drivers around the world. And then locally, if you bought a scratch card over the Christmas period and entered a code online to go on Marty Whelan's show, which I'm sure everybody in the audience did, well, that's our software. So we did the online system that you put the code into. We've also, Chill Insurance, if you got a code from Chill Insurance, that's us. So we do an awful lot of software that no one knows it's us. We operate on behalf of our customers. So I guess enough about us. Let's just give you an idea as to the sorts of range of stuff we get ourselves into. Just to look ahead, I'm going to go through a number of technologies and kind of give you the 30-second overview of what it is, and then some of the pros and cons of it, essentially. So starting out with the background on looking ahead at new technologies. So when you look at new technologies, usually you're in one of two camps. You're the hyper-optimistic, let's get stuck in and let's start building on it straight away. Or else you're the pessimistic, new technology never works, and you wait 5 years before taking on anything. Reality is, every piece of new technology goes through this Gartner hype curve, and if you've been on the conference circuit at all, you'll see this diagram again and again. And it's a brilliant visualization of the cycle with which expectations change within any piece of new technology. So at the very start, nobody knows about it, then rapidly people find out about it, then it starts getting its own oxygen, and everyone's raving about it being the next big thing. It gets to the peak of expectations, and all of a sudden, then a lot of people are implementing and realizing it doesn't do half of what was promised. Surprise, surprise. And suddenly it drops off pretty rapidly into what's called, I think, the trough of disillusionment from memory. Yes, the trough of disillusionment. But then finally people realize, well, do you know what? There really is a business case. It may not be as broad as originally expected, but actually there's more value here than I thought. And that's when it goes into common adoption, or it gets stuck in the trough of disillusionment. So that's kind of the cycle that different technologies go through. And I've highlighted here the various technologies I'm going to talk to. So AI, conversational AI, IoT, blockchain, mixed reality, and augmented reality. So they're the technologies I'm going to touch on now and just kind of give you a bit of a viewpoint as to what they are and so on. So first one up is, the why versus the what. So when you're looking at new technology, it's very, very important. You can go ahead and be technology-led and go, we need to do an IoT or we need to do an AR project, and kind of use technology to lead the project. But that's one thing that we shy away from. So we're very much focused on establishing the why. What's the business problem and the business challenge at hand? So the first thing we'll do is try and understand exactly what the grit is within the business. What's the problem within the business that we're trying to solve? And that then forms the foundation for the project that will then last a very long time and deliver value. If we start with just technology, it will start rapidly, but then also equally rapidly drop off. You can play buzzword bingo till the cows come home, but at the end of the day, when you're dealing with the people that pay the bills, normally they're not that techie. So you've got to somehow take what is a technology type thing and turn it into something that everybody understands. And it's a key thing is to be able to temper that hype. And that's a key that's a key part of our job as a partner, is to temper the hype and look at the real life applications of new technology. And ultimately it's a balancing act of having the right tech, right time, and for the right reason. They're kind of the key things that we try and bring to the table. So eventually got to IoT. So one major area, and this is one that we're heavily involved in, we got quite a few IoT projects in flight at the moment, and it took a while to get to this point. But essentially, IoT promises a lot of things, but ultimately what it really, really does is it automates the flow of business data. It connects the physical world into the digital world. I could tell you it's cyber-connected devices, but I won't use that phrase, I hate it. And I think if you do end up on the IoT track, this data becomes information, becomes knowledge, becomes wisdom. That is the mindset you have to make IoT real. Because data is just a number, 50. It means absolutely nothing. 50 degrees means it might be temperature, but it could be hot or cold. 50 degrees centigrade, well, now it's hot. So that's the kind of data becoming information. It's basic processing. But then how do you make it valuable? That's when you take the knowledge of the surroundings and the knowledge of the business use of that data, and that's when you get real value delivered into the business. And when you build out an IoT solution, you basically build it in layers, each one hopefully moving up along that value chain. So the knowledge is, well, if 50 degrees is in my fridge, I know I've got a lot of dead food. If 50 degrees is, off outside, well, then it's a pretty good number. So, that's where your knowledge and your wisdom come from. And the wisdom is what you do given the information that the system is showing you. That's kind of the hierarchy of progression. And ultimately what you're aiming to do is enable analytics and decision making. That's what you're trying to do with IoT, is to take away the clipboards from the business. So if you look through any sort of process and you see clipboards going around, more than likely IoT can bring some sort of benefit into that sort of environment. The main challenges that are there, though, is that IoT is connecting the physical world into the virtual, but to do so, the physical world needs to be instrumented. And that retrofit cost is actually quite significant on any large environment. And then also, for businesses, these days, anyone who's in like a managing director role in a manufacturing environment, for example, they've been told they should be doing smart manufacturing, they should be doing industrial IoT, but they're not quite sure how to go about it. So there's an awful lot of what we joke IoT is often the Internet of Talk rather than the Internet of Things. It's very hard to get people beyond that initial conversation and get them moving forward. So any questions, by the way, just as I said, throw them out. Blockchain. So of all the technologies I'm talking about, this is probably one I'm I guess, least enamored with. It's really, really cool and interesting from a technical perspective, but the more I look into it, the harder I see to get the real business value out of it. I guess, what is it? Well, it maintains cryptographically guaranteed truth. So once you establish a truth on the blockchain, it is impossible to change. You cannot change it. You can put a balancing value in there, but you can't change the original fact that was stored in the blockchain. And the idea is that the goal is to have an open, trusted, shared ledger. And it is a phenomenal idea, and it's really powerful. And one of the key use cases is supply chains, when you're going across multiple intermediaries. How do you have one master view of where your beef came from and so on? So having an open shared ledger where no one entity is managing that database and can actually change the values in the database, that's kind of a real value proposition that it brings. However, there are quite a few challenges, and one is transactional scalability. So that 7 versus 24,000 TPS, I didn't forget the K. It's not 7K, it's 7. So that is, the 7 is the transactions per second that's reported by Bitcoin, and the 24K is the transactions per second reported by Visa. So if you look at the two as a comparison, there just isn't one. It's multiple orders of magnitude. And scaling up blockchain means weakening the proof of work, which means weakening the cryptographic security. So it's kind of, there's a real chicken and egg type situation at the heart of blockchain's design that's going to be hard to overcome. Other one is internal facts versus external facts. If I look at a PPS number on a blockchain, I will trust that no more than looking at it in a database, because someone can put the wrong PPS number on the blockchain. And the issue with blockchain and the word trust, and the reason I have it in air quotes, or truth, should I say, is that with a traditional database system, you trust both the person that wrote the data into the database, and you trust the database itself is maintained, its integrity is maintained and not changed while statically there. Blockchain solves the latter trust problem. It doesn't solve the former trust problem. If you can somehow get a falsehood through an exchange onto the blockchain, it will be there forever and a day and will never be changeable. And there was a story there about a year and a half ago, where someone put a claim on a prototype blockchain around who owns what art, that they owned the Mona Lisa. And it was spotted and it was retrofitted, or it was fixed. But it was fixed with a countervailing thing saying, well, actually they don't. But if you look at the history of blockchain, for a period of time, they owned the Mona Lisa, even though they didn't. And that's one of the challenges that not being able to change data represents, is the real world violently clashes with it. Also, from a corporate ownership perspective, if I'm a corporation and I'm rolling out a blockchain solution, I like to have control over it. And the problem with the general blockchain solutions is that it's on a democracy, and there are problems with democracy, I guess. And it's the 51% attack challenge. So if one entity owns 51% of the compute on the blockchain, then they control the blockchain. So you could have an organization put a blockchain solution out there, and suddenly someone else puts a huge amount of miners on it, and then they own and control it and can then change it by virtue of voting for a change. And then the organization loses control of it. And that can be a challenge for organizations rolling out blockchain solutions. And the alternative is you don't allow others be miners, in which case you've undermined the distributed element of the blockchain. There's no point in saying it's distributed if you don't have other people doing the compute and sharing the load. And the final one about doing the compute, getting other people to do the compute means they got to contribute horsepower, CPUs, and there's a cost in that. So how do you pay them? How do you incentivize them to provide compute for free onto your distributed ledger? Blockchain's great. Bitcoin's great, should I say. You get money for providing compute if you win. But if you aren't generating money, if it's not a money-based thing, if it's just storing facts, how do you distribute cash and how do you pay people for that compute and reward them for that incentivization? It's quite a tricky nut to crack. So there's a few challenges that are hard to blockchain that I feel may be difficult to overcome. But I'm positive in everything else. As always, questions, happy. Augmented reality, I think augmented reality is going to fall on the positive side of, I think it was Bill Gates coined the phrase, I always get this one wrong, but I'll try and get it right. We always overestimate the changes in 5 years and underestimate the changes in 10 years. I think augmented reality in a 5-year horizon is going to make leaps and bounds, but I don't think it's going to be great. But if you look beyond that into the 5 to 10 year horizon, I think this is going to become a pervasive technology. What it promises is, I use the phrase, we close the loop on IoT data. As computer professionals, we're storing up a huge problem for the world in that we're now in the process of gathering so much data about everything in the world, people, process, machines, and everything, that digesting and making sense of and actioning that data is very, very difficult. AI and whatnot hopes to automate some of that, but ultimately humans need to consume it. One of the human mind is fantastic at spatial information. So using AR so that when you walk the factory floor, you see the information in the context of what you're looking at relative to that machine is a way easier way of exploring the data than going through 1,000 spreadsheets to find a report relative to machine B when you're actually thinking of machine A. So being able to provide the data that is being gathered by the physical world back in the context of that physical world is actually an exceptionally powerful concept. It started with Arnie Schwarzenegger and Terminator back in the 80s, but it will become reality eventually in the 2020s maybe. And essentially the idea is digital work instructions. So if you've got people who have been trained up doing jobs in a factory floor, you can actually have overlaid on their view of the real factory the instructions and the hand movements they need to do or the buttons need to press or the values they need to check. And essentially, but the challenges are, social stigma. I could have rocked up here with my headset on, but I think you probably would have laughed in my general direction. There is, a lot of technology required to be worn on the head at the moment, and that's probably one of the major things that technology needs to overcome is to make the form factor so small that it's completely transparent, essentially. Also, the cost at the moment is quite high. The cost of HoloLens is in the region of $5,000. Which is not pocket change. And then also the current solutions, the field of view is quite narrow. So we're used to VR where it might be 60 to 70 degrees, but with HoloLens and the augmented reality solutions, it's usually in the region of 30, 35 degrees, which is really, really narrow for practical uses. So it is prototype at this point in time, but I'd say this one is going to kick off in the near future. Next one up would be AI, machine learning and bots. I think this one's going to be the silent assassin, for want of a better phrase. It's going to silently, slowly but surely be pervasive in the office environment. That's ultimately it. Like there's an awful lot of day-to-day activities that people are doing, let's say insurance processing and so on, whereby bots are going to be able to just take over and automate a huge amount of work. So they can do the job of hundreds of people on simple menial tasks. So it's quite powerful. From a interaction with your customers, if you've got a very large customer base, if you can use bots to enable a natural language interface to your business, but served by non-humans, well then your costs go down. It is a cost play, let's not forget that. And essentially using machine learning to explore novel insights. Your experts are really, really good, but they might have inbuilt biases. Can you bring a new perspective by deploying AI and machine learning onto a large data set? That's kind of an area that could give a step change in productivity. Some of the challenges I've underlined and bolded, so it's very important that word relevant. It's all well and good saying you got lots of data, but is it relevant to the question at hand? And really, if someone has an idea about an AI project, the first thing you need to do, before even going down the route of defining what the AI project is, just make sure you got data, because if you don't have data or you don't see a path to getting that data, it's going to be very difficult to get much out of the AI side of things. You got to watch out for biased training sets, too small training sets, and so on. There's many, many, many caveats in that. But relevant training data is critical. From our perspective, when we take on projects, it's very hard for us to predict the project outcome. So when we take on a custom software build that's $500,000 in size, we sit down, we go through the requirements, we put together a product backlog, we do an agile process, so on and so forth. But we've got a very high degree of confidence we're going to get to where we thought we'd get to within a reasonable approximation of when and for how much. However, with AI, it's up in the air. The training data may not be exactly right. The algorithms mightn't exactly see what we thought to get. There might be different outcomes to what we expected. It might just take longer. It's a much more R&D focused type project than a traditional development project. So the organization within which you're doing AI and machine learning has to foster and enable a kind of a research mindset more than a development mindset. It's a capital R, lowercase d to get the best out of AI and machine learning. And ultimately, going back, it's kind of a similar echo of the blockchain concern. If you do an AI solution within your business, you lose control over the explainability of the process. AI is really good at doing kind of novel insights and so on. However, it's very bad at explaining why. You can always ask a person, what were you thinking? You can't ask an algorithm that. And some people have deployed AI on algorithms where you've got AI making a decision, you've got further AI working out what the first AI was even thinking. So it's layer upon layer upon layer. But that's one of the main challenges in widespread adoption. If I'm an insurance broker and I've got a central bank mandated liability on anything that my site says or does, and I deploy AI into the mix and it does something crazy, I'm liable for it. Are you going to stand up as the financial controller and stand over that risk as your business? These are the sorts of challenges and conversations we have when we talk about bots. So, bringing it back to developers, I guess this is dev kickoff, I guess. The world as a developer is changing rapidly. I haven't developed myself hands-on for a couple of months, but really a couple of years full-time. And how development is done now has changed massively. The whole idea, the key fundamental notion is that hardware is being abstracted away to the point that it doesn't matter. Hardware is this thing that you just turn on. So containerization abstracts the operating system and even abstracts the services and whatnot. So you've got serverless architecture, containers and so on that really there's no need for a physical server anymore. Also a lot of automation at the hands of developers whereby we can script the creation of a server farm. However, the problem is it's kind of handing developers a loaded shotgun. And this is one of the concerns I have. If you're able to script the creation of a server farm, and you accidentally create 1,000 servers rather than one server, and you don't realize until 2 weeks later when your financial controller is giving you a shout, you've got difficult questions to answer. And it's very doable. And there's the story from years ago about the $1 million database that was spun up on Azure in the early days, and the company's liable. And that's the nature of the beast with this serverless computers, that is very, very easy in the dev environment to accidentally cost an awful lot of money. So having controls and processes in place, it's like being given the tool, but then it's kind of half taken away again. So it's a balancing act there that we still have to figure out as a development community, how best to manage that. So, how do we use this new technology and how do we make it real? How do we go about the process of turning that concept into concrete? I'll be sappy and say we turn dreams into reality, man. But essentially, we sit down with someone who goes, I wonder if, and 6 months later we've got something physical in the world that's actually doing a job. It's development. I love development for that reason. It's just so creative. But there's many project pitfalls. There's many areas where those dreams turn into nightmares. So how do we manage that and how do we avoid that and what do we look out for? So there'll be 3 main pitfalls that we'd be looking at. So number 1 would be unclear objectives and unrealistic expectations, and finally tentative stakeholders. They're kind of really the 3 main drivers for project challenges that we've come across over the years. So what do I mean? Well, with unclear objectives, don't let the techies rule the roost. Sorry, I'm techie, so I'm allowed to say it. We love technology. We will go into a rabbit hole to the nth degree. We'll figure it all out, and we'll spend all the time in the world doing so, which is great. It's fantastic, but it has to be technology supported, not technology led. If you drive a project forward, anything other than in the R&D space, if you're out there delivering value to customers or value to stakeholders, and you drive it just purely on the technology side alone, there's going to be challenges. It has to support a business goal. But then when you look at a business goal, you end up faced with stakeholders that have unrealistic expectations. So the challenge with everyone who's non-technical is they go to technical conferences and they see that 30-second demo of some guy hooking up an IoT device into Twitter and having a tweet when he shakes a sensor, and then they come back going, right, we got IoT next week. Excellent. Somehow that's unrealistic. And having that ability to manage expectations and have those conversations and scale back expectations into into the realm of reality, whilst communicating not as a techie, but in the other person's language, because they're never going to understand you. That's a key thing in development. It's very hard for other people to understand you. You have to start understanding their perspective. Have that discussion in their context, from their perspective. And if you can do that, well, then you get to the holy grail of the ultimate balancing act. And kind of like, skiing and snowboarding and ice skating from the outside, it looks really easy, but it's actually really, really difficult. So getting that balance between tech-led and tech value and tech passion, not crushing the drive that the techies bring to the table, but also supporting the business goals and everything else is very important. And I mentioned the stakeholders, the staking down the stakeholders. Ultimately, in most organizations, they're pretty much top-down. And if you have a stakeholder at the top that isn't quite sure if this is going to deliver value, or they're not in the loop, well, then they can actually be they introduce uncertainty into the project team, and then the whole thing falls apart. So getting the stakeholder who's totally abstract from the project on board is yet another layer of communication. It's critical to success of these sorts of new technology projects, because ultimately, I don't envy those people running large manufacturing plants, because they're being asked to spend 100 grand on an IoT initiative. And then they turn around to the finance guy, and the finance guys go, well, we're going to get a 3% return on 100 grand on a new machine, and here's the spreadsheet, and it's exactly right, because we've done it 1,000 times before. And meanwhile, there's a techie guy going, oh, it's going to revolutionize the business, man, gives 100 grand. Well, tell me why. Well, it will. And it's a very hard decision. They got to segregate innovation from business as usual. So getting the stakeholders involved and being able to get them on board is something that's very, very important and very hard. So then, you've convinced someone to take on new technology. You've convinced them to take a punt on IoT. And of course, the first question that's going to be asked is going to be some version of how much will it cost, or how long will it take? They're synonyms for each other, let's be frank. We get paid by time. So the trouble with it is it's the smallest word, but the biggest impact in that sentence. And it requires a whole lot more than the obvious requirements. That's a critical thing. We can say we want to do, automate the data acquisition from a machine. Okay, so how do we do that? And you got to go into the weeds a little bit and then come back out again. So as an example, we've got a project budget discussion that went on a year or two ago that became kind of my touchstone for this exact challenge. So we had this team come to us, and they said, right, we want an app for a smart light bulb. And they were probably the best prepared team that came across our doors. They had the light bulb already developed. They'd done all the hardware development. They had the whole thing ready to go. It was a smart light bulb that you could get energy readings from, hours on, hours off, lifetime left in the bulb. All this sort of stuff was available from the bulb electronically. And they said, right, we just want an app, and here's the 50 screens that we think, well, actually, sorry, it's 5 screens. Here's the 5 screens that we think are required to deliver the app. So how much is it going to cost? And we're like, there's a bit more to that. And they're like, no, we've it all thought out, this is it. Like, well, there's a lot more to it than that. So, we said, right, you've got development costs for starters, obviously, operational costs when we run it, then road mapping versions 2, 3, 4, 5, 6, device management, customer service. And then within each of those, you've got a ton of other things to think about and discuss. And one example that we did go deep into was, okay, so IoT device management. So you've got the bulb. That's great, but just think about the person who has to install the bulb and configure the bulb. Well, they take the bulb out of the packet, stick it into the socket. Well, now, how do you get the code off the bulb? You've got to enter in the apps as the app owns the bulb. How do you get the bulb talking on your Wi-Fi, or is it Bluetooth? Is there a Bluetooth chip in there? There's so many different questions that started coming out of it. They're like, oh, crap, we should have talked to you about a year or two ago. And that's some of the challenges to come about from jumping into the technology first. These were hardware engineers, and they built a fantastic light bulb, but weren't aware of this whole wide ecosystem that's there. And that's a big part of our conversation, is that when a project comes along, we go, right, do you realize that this is where it could go? And we talk about the whole end journey, the end goal, and what the potential scope of it could be. But then we quickly go back to, right, let's go and do the MVP. Let's do the minimum. Let's start out with just a bulb, but in the context and knowledge of the wider investment that may be required. So then, zooming back in again on something concrete. So Iot Predict is a product that we developed in partnership with Dell, Intel, and Microsoft to solve a key problem in industrial IoT, which is there's very few platforms out there that allow manufacturing companies to get started rapidly on the industrial IoT journey, but also will stick with them for their enterprise journey over the next 5-10 years. There's a lot of quick start platforms that get you 6 months down the road and then have to be turfed out for something enterprise. And there's a lot of very expensive enterprise stuff that costs 200 grand to even deploy. So we try and fill the gap there. It's quick start kit, but it ends up basically getting someone into a situation where the hardware they've deployed and the software they've deployed is enterprise grade and able to scale and grow and integrate with their wider software ecosystem. So the reason I'm talking about it is not to sell you guys Iot Predict. It's to give you, I guess, some insight into some of the mechanics. Again, it's a semi-technical room. So just to talk through the architecture of an IoT solution. So what is the architecture of Iot Predict? How does this thing work? What are the actual moving parts? So ultimately, we go into a factory floor and all they have is moving machines or vans or trucks or robots or whatever it is. So what we do out of the box is we got temperature, current, and vibration are the three sensors. We physically install them with M8 screws surface mounted onto equipment. Those sensors are then wired up to a Dell Edge gateway that runs software we built to do store and forward. So it takes the data real time, stores it up, batches it, and ships into the cloud every maybe 20 seconds, 30 seconds or thereabouts. So that gateway then is talking up to via secure connection to Azure Iot Hub, which is the entry point into the Azure cloud for IoT data. And essentially, Iot Hub is essentially like the train station, and it routes the data appropriately. So once up there, it goes into 3 distinct destinations for 3 distinct reasons. Again, the technology used here is only semi-relevant. It's more the reasons why. Remember, the what's not relevant, it's the why. So why do we use time series insights? Well, a key part of IoT data is getting it in front of people who know what the hell the data means. So you got to give the experts a tool to allow them to kind of swim around the data and try and figure out some insights. And that's what this time series insights tool does. It allows the experts to look in and figure out some algorithm or pattern or something that they would like then to look for real time. So then, of course, they come up with an insight and they're like, how do I actually automate the monitoring of this particular pattern? Well, that's where the second part of it comes into. There's Azure Stream Analytics. So Stream Analytics allows you to look at a live stream of data in semi-real time over a sliding window of, let's say, 30 minutes or 60 minutes or whatever, and allows you to do, if temperature's gone above this and stays above this for more next minutes, well then do this. It's moderately simple language, but it's a great tool for doing that quickly. And ultimately, in our Iot Predict product, out of the box, you get temperature alerts, vibration alerts, that sort of stuff. It's fairly straightforward. And then the final one is Blob Storage. So again, the phrase is data is the new oil. Your data is very important. And if you're entering into the IoT space in order to enable an AI process down the line, well, if you don't start gathering the data from day one, you're just letting money go through your fingers, basically. So having Blob Storage to store the data is critically important. So that's kind of every single IoT solution will have different technologies, but they will be addressing all of those same concerns. There are common concerns across most IoT solutions. So then you were talking about, okay, we need to scale this up. How do we do more stuff? So that's where we can add in machine learning on the data flow pretty easily. So that's a custom integration. Another one is integrating with the likes of SAP, Salesforce, any other kind of third-party systems. Maybe we might raise a ticket in a help desk application if temperature goes above X, or we might push something into an ERP system. These are the sorts of things that you can then integrate with once you get certain insights. Also on the edge, at the moment we come with those 3 sensors out of the box, but we can actually talk to SCADA systems via OPC UA. We can physically connect to CAN bus systems. We can plug in serial ports and so on. So having loads of different data integrations on the edge is very, very important. And that gives you kind of the roadmap for how your software platform is scalable over X number of years within enterprise. So to make that real and to talk about a case study, and this is near enough the end. So basically, we worked with a company in the water treatment facilities. And water treatment is a euphemism for sewage. So it was a lovely project. And we kind of, what's your grit? What's your challenge? Where's the problem? What do we use modern technology for to try and solve? And what came about pretty quickly is that they spend an awful lot of time just monitoring, just looking at the plant. And there's a huge amount of manpower involved in monitoring, looking at the plant. And so we kind of asked them, well, what are you looking for? And one of the things that came up pretty quickly is suds. So basically they said they look at the surface of water to see are the suds the right kind of suds. And the right kind of suds look wrong, so the wrong kind of suds look really wrong. And essentially, when you look at a sewage plant, it's really just a big chemical reaction. And these guys are feeding in air, they're feeding in chemicals, they've got a SCADA system managing all that. And if everything works perfectly, well then the suds will look right. But what can happen is the SCADA system can say, yeah, all is good, but actually there's a blockage in a valve. The valve is open, but there's a blockage, and hence the air doesn't flow and the suds don't happen. So we're like, okay, well, maybe we might be able to use some sort of machine vision tool to try and see if we can work out are the suds correct or not based upon the status or the shape, whatever it is. So what we did was we went back to the Iot Predict architecture, so same architecture as before. So the first thing we did was we changed out the sensors. The 3 sensors I mentioned are irrelevant. So instead we used OPC UA to talk, OPC DA actually in fact, to talk to their SCADA system called Wonderware and to pull in data from us. We pulled in about 40 tags about what's happening in the factory. Again, the valve? Is the air blower running? What's the pH in the water and so on? So we pull in all this information to the system and ship that up into the cloud. So that's number one. And that's kind of the core IoT functionality. But then what we did is we layered in cognitive services. So in Azure Cognitive Services, or Cortana as she's commonly referred to, essentially we got about 300 or 400 photographs of suds on water, foam, and ran them through a model and trained the model in the cloud. So we trained the model on a high compute environment so as that the model can basically spit out one of three values. It is being aerated, it's not being aerated, or I'm not quite sure. So all of this technology boils down to one of three values fundamentally. So once that model is trained, we put that on the edge, and that's now running on edge compute in a fairly lightweight compute environment. And the purpose of that is to ship up into Azure Iot Hub a 41st tag called aeration status. That's all it does, sends up aeration status. Once that was done then, we stored that into Blob Storage, so you got a trigger of what the aeration status is alongside the other 40 odd tags of data. We also updated the alerting rules so that if the aeration status changes from anything to bad, well then we send out a text message and alert. But what we did as well is we used the status of the SCADA system to go, right, the suds are wrong, but we see the air blower is off, so probably your air blower is off. So we helped with the decision support. We didn't just say, it's wrong, go look. We kind of tried to give some advice as to where the problem could be as well, based upon logic trees, basically. And then when that text message goes out, the idea is that you get a link on the text message. So what we built is a web application. Sorry, in that case, we're storing up the image as well. Sorry, so along with the data, we also push the image of the foam up into the cloud. So alongside the data going through IoT Hub, we store an image into Blob Storage as well. And then the last thing is we put a UI in place, a very simple UI. When you hit it, it shows you the current status and the image. And what happens then is you can close the loop in that the guy now gets a text message to say there's something wrong. They click the link on the text message, and that brings them to this page, and now they can see a live view of what the foam currently looks like. And then that decides whether they get out of bed or not, which is a whole lot better than not finding out till the following morning. And then the final thing we did on it is we closed the loop as well, in that SCADA systems are very, very, very closed environments. You don't get data into a SCADA system easily at all. It can't reach out to a web service, pull in a JSON, parse it, and lob it up in a HMI. It just doesn't work. So what we did was that aeration status that we had calculated outside of the SCADA system, we wrote that value back into the SCADA system as another tag that the SCADA system understood, and that allowed the automation engineers to update the HMIs that are on display in the monitoring facility so that they have a simple red, amber, green traffic light there that's a reflection of the status that we derived. So you now have an old school HMI in a NOC in a plant where the value is actually coming from machine learning on an edge platform. So that's kind of how the whole lot came together and how the data flowed and the whole solution was successful. And I guess then the final example of many conversations we're having, going back to my augmented reality viewpoint, is that we've had quite a few conversations with organizations around this notion of holographic smart stacks, as we're calling them. So the stack, if you don't know, is oftentimes in the factory you'll see there's a simple traffic light on the top of very strategic points in the factory, a red, amber, green. That's called a stack for whatever reason. I don't know why it's called a stack, but that's the name. So we're calling them holographic smart stacks. So the idea is that if you put on a HoloLens and walk the factory floor, you'll see a holographic version of a stack, but it's something now that you can tap. And when you tap it, it knows you're the operational guy, or you're the finance guy, or you're the maintenance guy. And depending upon which person you are, what your role is in the organization, it'll pull different relative data from the vast troves of data that are coming off the factory on a daily basis. So it kind of goes back to closing the loop, that idea of closing the loop on IoT data and making the data that comes from the physical available back in the physical. That's where AR is going to be a killer app. So I guess lessons, if I was to really kind of summarize what we've learned the hard way many times. Buy-in and balance from the end user, business, and IT are key. So, as developers, we're very much focused on the technology, but there's a whole ecosystem of stakeholders out there, and if they don't all buy into what you're trying to achieve, then they're going to make your world difficult. So the more you can take your head above the parapet, look out there, find all the stakeholders, and have those conversations in their language, the better. When we look at bringing new technology to bear, we definitely focus on evolution versus revolution. Just small incremental steps give huge visible value quickly, versus revolution where you disappear off, come back in 12 months' time, and there's no one there to see the great thing you created. That small change having a big impact is massive, because the stakeholders who are not technical are looking at it from an ROI perspective, and the quicker you can demonstrate that, the better. And to that point, everything that an organization does is normally technology supported rather than technology led. And that's a critical thing to support and understand. You work out what the business reason is with which you can get your technology project over the line. You don't try and get the technology project over the line on its own. And essentially identify and solve a real problem. That's the critical element. Come up with a real nuts and bolts issue that's facing the business, a wastage, an inefficiency, something like that, and work out a way to put a solution in place that'll then help everybody around you, and you'll be the hero forever and a day. So I think that is pretty much it. I'm happy for any questions at all, so thank you very much. Cool. I answered them all in flight, eh?
You have talked about or nothing.
I have to. Cool. Brian, thank you.
Very much.
Cheers.